Today we're going to talk about your volume and tone pots, what they do and how they do it. Afternoon, you fuzzy lot. I hope your week's been good and you're looking forward to the weekend. My name's Marcus and this is the Friday finish. So, volume and tone pots, how they work, what they do and why they do it. First of all, why would you need to know this? Well, I guess the first reason is if you've got a guitar and you love how it plays, but you're not necessarily connecting with the tone, there are some simple things you might be able to do ahead of changing out the pickups. And a lot of that might be connected around the tone and the volume circuit. So we'll get into how it affects the tone a little bit later, but for the time being, let me just describe how they work, which will give you a better understanding of where you might be able to go if you wanted to make some changes. Plus, a little bit of knowledge is power, in all honesty. So what is a tone pot? Well, it's a variable resistor. So what is a resistor? Let's break that down into the two. A resistor is a component that here's a bunch of them. There's a bunch of resistors there. It's a component that basically a signal, be it AC or DC, comes into, hits this part, and it is restricted. Depending on the value of the resistor, it basically cuts back how much of that signal gets through. It resists it. So that's what's known as a fixed resistor. And then you then have a variable resistor, which, you know, if anyone's ever peeked inside a pedal, that's the thing, and that's what you turn on the top of your pedal, or in this case, in your guitar. So that is something that will vary the amount of resistance. And they typically have, I don't know whether this is going to focus. No, it probably won't. Can I get it to focus? No. Anyway, there's that white bit of printing on the top there, and that tells you the maximum resistance of that resistor. So it goes basically from 0 to 100%, and 100% is, for instance, in this, it's a 250k pot, so 250 kilo ohms is the maximum that resistor, variable resistor, will go to. It will go from 0 to 250. So it'll at 0, just rest it there. At 0, it has no resistance. Okay, and at 250, it has 250 k's of resistance. So how does that work in your volume scenario? Well, that will take a diagram. Okay, so let's get into the nitty gritty. You have a pot, okay, and it has 3 lugs. Okay, now this is known as a center wiper, and that is typically either in a pedal or in a guitar, the input or the output in the center. So on a guitar, that is going to the output. Okay, that will go to your jack. This tag will go to the switch and then to your pickup. Okay, so there we are. This one goes to earth. Now the way the pot works is that at either point you have your 2 extreme points there. If it's turned to one point, the resistance, say this is a 250k pot, okay, when you have it all the way around this way, the resistance between this lug and this lug is 250k. When you have it turned all the other way round, between there it's naught, but between there is 250k. And then anywhere in between will vary. Say this is 100k here, you have 250k here. So the sum of these two will always add up to 250k. I hope that's fairly explanatory. So how does that work in a guitar? Well, when you have your guitar what's known as wide open or on 10 flat out, basically the resistance between the output and the earth going to ground, that's where it's 250k. There's a resistance of your signal going to earth. It's resisting sending it to earth. And so that means the majority of it is coming through, and because the resistance is zero there, it's going out. Okay, it's going straight out your pickup, from your pickup out to your guitar. Now there is a certain amount that is bleeding to earth. Okay, but that sets the tone of your guitar. If you notice that on a Les Paul, typically these will be 500k, is because and so this resistance here would be 500k, twice this. That will let a bit more treble through the output. It'll bleed off less. There's more resistance, so it'll bleed off less signal. And because Les Pauls are typically darker, so it needs to let a bit more treble through. And as you turn it down, excuse me, as you turn down this way, you're reducing the resistance of the signal to earth. Okay, so more of the signal will go to earth. Eventually, when you get to this point here, where that is zero resistance, there is no resistance of your signal going to earth, means all of your signal will be going to earth and nothing will be coming out your output. So that means it's quiet. So when people say they run their volume wide open, it's kind of a misnomer, because it actually means that that's where the maximum resistance is. But it's maximum resistance to earth. Okay, so let's talk about the tone knob. Similar sort of setup. Now, but with the tone knob, it's what's called a trimmer. So that one is not used. Okay, so you have your signal coming in, and then you'll have a capacitor. Okay, now that capacitor will go to ground or go to earth. Okay, so now then, let's assume that this again is a 250k pot. So you have a capacitor, and in front of that a variable resistor. Now, there's a common misconception that when your tone knob is rolled all the way up, so you're set it at the brightest tone, the capacitor is out of the circuit. That's not actually true. Okay, because let's put the maximums on there. This is what's known as an RC filter, a resistor capacitor filter. So if you put a resistor and a capacitor in series, it filters your sound. Okay, it will take a certain element of the audio spectrum out. So when your tone knob is set at its brightest setting, as explained before, the resistance between these two, whereas your in and your to earth, is 0. It will just be employing the capacitor, and the resistance part of the RC network will not be in it. The capacitor will have some effect on your tone, quite a small one, but if you change that capacitor, it will have an effect. Whether you notice it or not, it will have an effect. Okay, as far as electronic theory is concerned. What then happens is, when you turn this round and increase this to a maximum of 250k, combined with the capacitor will cause filtering. So it will increase the effectiveness of the capacitor, but at no point in that rotation is the capacitor not in the circuit. So what is the practical application of doing this? Let's take an example. If you've got a Strat and it sounds a bit dull, it can happen. I've had Strats that are, not really got that cut and that punch. Typically what people will do is go to change the capacitor. That can make a difference, but it's a minimal difference. The bigger difference, to be honest, is to change the pots out. It's a slightly bigger job, but not as expensive as swapping out pickups. And it might not be the pickup. It might just be a combination of lots of things. The woods, the neck, your rig, all that sort of stuff. There's lots of things you can do to change that, but one of the things you can do, change the pots, and that will have a global brightening effect on your guitar. Same as if your guitar's too bright, it may be that you want to change from 500s to 250s. That will take out quite a lot of the top end. It doesn't mean to say you've got to go a whole hog and change your pickups or just sell the guitar. It might be, there's somewhere short of something as drastic as that, and expensive. I hope that has kind of enlightened you to how pickups work. It may well have confused you even more, I don't know. If you have any comments, any questions, if you think I've got something wrong or you want to debate it, comment it. Let's have a discussion about this. Anyway, hey, thank you so much for listening. That's it for another week. I'll look forward to seeing you on Monday for the Monday Minute, where I'll quickly go over what's going to be happening in the week ahead. But in the meantime, have a fantastic weekend. My name's Marcus. This is Reeves Electro, and that was the Friday Finish.